to incorporate content. That stuff you have to treat just the same way. Another situation is when you're dealing with sometimes a lot of, and I'd say maybe most, web applications that are developed and used internally. So you're working with employees, and kind of the expectation is that, well, the employee's not going to do anything bad, right? Either accidentally or maliciously, employees can do stuff that's going to goof with things. They could just accidentally type something in that messes stuff up. They could hit the button the wrong way. They could interact with the application in a way you didn't expect. Or maliciously. It's very easy to get an employee who sort of knows some stuff about these things and isn't happy and decides to do something bad. One thing that occurred to me while I was working on this, although as far as I know it's not been done, there's really no reason that a piece of spyware that existed on, well, usually a Windows box, a piece of spyware that exists on an employee machine could attack a web application. Lots of spyware interacts with the browser. There's no reason that it couldn't say, somebody couldn't write a piece of spyware that infected an employee's machine, and then you're behind all your firewalls and stuff like that. You're working on a trusted machine, and could easily go in there and wreak havoc on a web application. And that's why you don't trust employees. So I'm going to talk about some basic scripting practices against some of these attacks. Again, my emphasis is going to be on PHP, but these concepts should be applicable to pretty much any of the major scripting languages you're working with, or other kinds of things. PHP has peculiarities about it, but it's where my background is strongest. And again, lots, if not the majority of this work is being done in PHP. Protecting against form spoofing, a basic thing with that is you need to limit acceptable input in any way you can. This is an example, a simple switch case statement structure. Realistically, this isn't just something that you protects against form spoofing. This is something you should be doing against any kind of attack with any kind of input. If you can limit the kinds of things that you can expect, you should absolutely limit it. It should only be allowed these certain things, and you should only whitelist these certain particular values, and anything else should die immediately. It should just kill the. It should not be allowed to continue executing. Again, this is a basic case where you really don't have to do any filter. You're not doing a filtering in the sense that you're not manipulating the input. You're just checking. Is it this? Okay, then do that. Is it this? Then do that. If not, die immediately. Again, you're setting in this case just two whitelist values, and then you're cutting out right away. Some other stuff with form spoofing. This isn't something that makes it impossible. It makes it harder in the sense that it raises the bar to some extent. Depending on who you talk to, if they really know what they're doing, they say, well, this is trivial to do. But realistically, most defenses are not going to rely, well, you better not, rely on one kind of defense against attacks. You're going to want to have a series of defenses, multi-layered defenses. And this is one way that you can really eliminate a lot of folks from doing stuff, is you use something called shared secrets to make spoofing harder. Again, it does not make it impossible by any means, but it makes it harder. Basically what you do is you make some kind of one-time hash, and you want to make it a hash that's next to impossible to predict. So you don't just MD5 something. You would say MD5 something with, there's a unique ID value, or unique ID function that PHP uses to randomly generate something. And you MD5 that, so then you've got a nice 32-character hash. You don't use a standard one because they're easy. You can, it's actually kind of easy to crack those, especially with MD5 libraries that are out there. But anyway, you create a hard-to-predict hash. You store it in your session, which is sitting on the server. And then you echo that out as a hidden field in your HTML form. So it exists on the client's machine as it says hidden. It's not really. I mean, anyone can just open up and view the source and see the value. But basically, for each time they request a form, they get a cookie. Each time they do that, they get a new hash. It doesn't make it impossible, but it really makes it harder. It makes it very hard. Shouldn't say that. It makes it harder to automate the process to some extent. Somebody really has to know what they're doing to do something to not use your form in this case. And again, it doesn't eliminate it, but it makes it harder. With the other basics with form spoofing, there's a couple things here to say that don't really work with it. CAPTCHA, which I can't remember exactly what it stands for, but it deals with the Turing. It's some long thing for Turing test stuff, where basically you have some squiggly looking letters, and somebody has to look at that and type it in and say, okay, this is what it says. This says SMWM on it, right? Sort of. This really isn't effective against human attackers, but it's useful against automated attacks. And usually what you're trying to do is you're trying to defeat spamming with that. CAPTCHA stuff really is not effective against attacks against something in the sense of an attack where you're trying to find a vulnerability in an application and screw with it. The refer, which is in HTTP, that is supposed to indicate where the person who just arrived at your page, where they came from. That's completely not useful because that comes from the client and can be manipulated extremely easily. Anybody with a basic understanding of a program like curl or wget can change that. That is absolutely not useful, and you shouldn't even try to mess with that. Basically, again, the idea that you should be using for all of these is that you want to use multiple approaches in conjunction with filtering and sensible design. You don't want to rely on just one kind of thing. You want to have a multi-layered defense against your stuff. Protecting against HTTP spoofs, it's basically the same thing as form spoofs. If you design your stuff properly, if you think about how people are going to work with your stuff, you should be able to block it. If you've done your filtering right, it's going to work with this stuff too. The danger with HTTP spoofs is that folks can do who know how to do that can do more stuff and more complex stuff. This is where things like PHP's register globals setting gets really problematic because whatever they pass in, say via get or post, is automatically converted to a variable. If you're not initializing the values for your variables automatically, somebody could conceivably overwrite a value that ends up in your script. That's why you don't use register globals ever. This protecting against cross-site scripting. Basically, the first thing is that you need to strip all potential client-side scripting out of any input that you get from the user. This is an example of how JavaScript can be embedded in almost any kind of HTML. This is just a bold tag. And you think, well, bold tag, it has no action associated with it. It doesn't go and grab anything. It's purely a formatting tag. Yeah, but most browsers are going to still have the ability to associate an action with it so that you bold this, but then you also associate this action on mouse over with it. And so if somebody has JavaScript turned on and they have this set up there, when they roll their mouse over the part that says, hey, look at me, it will execute this JavaScript, which is doing the normal thing that it showed before. It's passing. JavaScript grabs the cookie stuff out of document.cookie and then sends it off to this script existing on another site. Really, if you want to be smart about it, you should just eliminate HTML input entirely. It's generally, for most applications, you're going to be doing, most of these things are for forums, for guest books, things like this. If people are wanting to post content, they're just going to want to do formatting. So you should probably consider some kind of alternate markup set like BB code, wiki-style formatting, stuff like that. These things are much simpler, and you have the option to, because you're doing the interpretation from that markup language into HTML, you have a lot more control over what gets out and what doesn't. One thing that's interesting, again, this is specific to PHP, but just introduced into the pair library, I think 2 days ago, was an alpha version of this library called HTML Safe.